we're doing a video on
sound.
Sound is a longitudinal wave that is created by a vibrating object. Moreover,
sound can only be created or transmitted through mediums such as a liquid, a solid, and a gas. As we will see, the particles of the medium must be present for the disturbance of the wave to move from place to place.
sound cannot exist in a vacuum.
What's really cool is to play some sounds into the tube and you can actually set up standing waves. That is, there are areas, there are patterns of the vibration of the air where there's a lot of vibration in some parts and not very much vibration in other parts. Now that affects the flow rate of the gas inside that tube into the atmosphere, and so it affects the height of those flames. So basically you can visualize the standing wave pattern.
Sounds travel at different speeds through gases, liquids, and solids.
This is because their molecules are spaced differently. For example, air molecules are much farther apart than the tightly compacted molecules of steel. The closer molecules are, the less distance they have to travel or vibrate to transmit energy to one another.
And the faster the sound wave can travel.
The speed of a small amp wave on a string can be calculated with the formula for velocity to determine the speed of the sound wave. The formula involves v equals the square root of f over m divided by L. In this case, F is the force of tension on the string, m is mass, and L is the length. The denominator includes mass divided by length, which is also called linear density. To calculate the speed of the sound generated when Roy played the musical note E on his guitar, we will use the formula for the speed of sound. The tension applied to the string is about 226 newtons. The string itself is 0.208 times 10 to the negative third kilograms, and the string is 0.628 meters long. When these values are plugged into the equation, we get a speed of 826 meters per second.
The frequency of a wave refers to how often the particles vibrate when the wave passes through the medium.
The sound waves coming off of the viola string look very much like the waves pictured in this drawing, like a sine graph. The particles of sound are a point along the graph as it moves.
Produced by a moving source of sound waves that causes a noticeable upward shift in frequency for an observer whom the source is moving toward, and a downward shift in frequency for an observer whom the source is moving away from.
It is important to note that the effect does not result because of an actual change in the frequency of the source.
So this is our experiment on the Doppler effect. First, we're going to drive away from the camera so you can see the difference from start to finish, and then we're going to drive towards the camera.